Hey guys, today we're going to talk about simplifying fractions using prime factorization. So we spent the last couple of days using prime factorization to help us find the greatest common factor in a set of two factors. Now let's take that one step further and use the greatest common factor to simplify a fraction. Now basically what I mean by simplifying a fraction is we like fractions that have nice small numbers. We like when there's a 1 in the numerator or when there's really little numbers in either the numerator or the denominator. What we don't like is big giant fractions. Big giant fractions that have large numbers in the numerator and the denominator, they're a little bit harder to work with and they're a little bit harder to figure out. For instance, if I wanted to draw a picture of 1/2, super simple. Just cut a circle in half, draw one shape in. But if I wanted to draw a picture of 10/20ths, oh my gosh, I'd be here all day long trying to get 20 little pieces and then coloring 10 of them in, and I can't do it. So we like nice little numbers when we're working with a fraction. And the rule is, when you're working with a fraction, you need to have it simplified. It needs to be as small as it can be. Now, here's how we do that. We've already worked with equivalent fractions, and we've already talked about you can make equivalent fractions by either multiplying or dividing the numerator and denominator by the same thing. So, for instance, if I divide the numerator 3 and the denominator 6, if I think of number that goes into them evenly, I know 3 will go into both 3 and 6 evenly. And if I divide both of those by 3, I end up getting 1/2. There's no other number that I can evenly divide into 1 and 2 other than 1, which won't make it any smaller, that will make this fraction smaller. So this fraction is what we call simplified. It's as small as I can get. There's no other numbers that I can divide evenly into the numerator and the denominator to make that fraction smaller. That's what we mean by simplifying a fraction. We want to divide the numerator and the denominator by the same number so that we get a nice new fraction that's itsy bitsy teeny weeny, and that's a lot easier to work with. So today we're going to talk about simplifying fractions, and we're going to see how can I use prime factorization to help make that a little bit easier. So sometimes when we're simplifying fractions, it's really easy. You might have a fraction like 5/10, and you might say to yourself, dude, that's easy. I know exactly which number goes into 5 and 10 evenly. I can divide both 5 and 10 by 5. I don't need to do anything fancy for that. I can do that in my head. 5 divided by 5 is 1, 10 divided by 5 is 2, and we have another fraction for 1/2. You could maybe even do 10/12, and maybe you say, I know that I can divide 10 and 12 both by 2 since they're even, so I can make a new fraction by dividing by 2. Now, when we're simplifying though, sometimes we have to do a little bit of extra work. Sometimes you might get a fraction, you might try to simplify a bigger fraction, and you might say, you know what? I know I can simplify 20 and 30. I can simplify them both by 5. I know I can divide them both by 5. So I'm going to go ahead and divide by 5, and I get 4/6. But if I look at this fraction, I know, wait a minute, 4 and 6 are both even, which means they can both be divided by 2. So I can keep dividing. Well, that was an extra step to throw in there. And if I keep dividing, I end up with 2/3. And I finally get to the point where I know 2 and 3 are both prime numbers. I can't divide them by anything else, so this must be done. So what we're looking for is we're looking for the smallest fraction possible. Sometimes we have to do multiple steps, and prime factorization helps us do that. Now, one way that you can keep factoring down a number as a fraction, you can keep simplifying a fraction by taking multiples that are small and easy and dividing by those. You might say, 12/20, I'm going to divide both of those by 2. And if I divide both of those by 2, I get 6/10. And I'm going to divide both of those by 2. And I can divide both of those by 2 and get 3/5. And this is now a prime number. But sometimes you get bigger numbers, you'd be dividing forever. So what we can do instead is use prime factorization. Let's go back to the fraction 12/20ths. I have a numerator of 12 and a denominator of 20. If I think back to yesterday's lesson where we talked about prime factorization, I can figure out the prime factorization of 20 and 12 and get my greatest common factor. What we're going to do is we're going to find the greatest common factor, and I'll show you how we can use the greatest common factor to simplify this nice big fraction. So I'm going to factor these down. I'm going to think of numbers that I can multiply, two factors of 12, and when I get to a prime number, I'm going to circle it. So I know 3 times 4 is 12. I'll circle that. 4 I can factor down into 2 times 2, and those are primes, so I'll circle this. So the prime factorization of 12 would be in order 2, 2, 3. All right, cool. For 20, I could do 2 and 10. That's a prime number. And then I could do 2 and 5. These are both prime numbers. So the prime factorization of 20 would be 2, 2, and 5. Now, we learned about when we're working with greatest common factor, using a Venn diagram can help us figure out the GCF, the greatest common factor. So I'm going to take the factors of 12 and the factors of 20, and any number that they had in common I'm going to write in the middle. So they had 2 in common and another set of 2. So I'll write 2 2s. 12 had a 3 left over and 20 had a 5 left over. If I look, the greatest common factor is the product of the middle of my Venn diagram. So 2 times 2, or 4. So in this example, the greatest common factor of 12 and 20 gives me 4. Now, you may be saying, okay, that's great, but how's that going to help me simplify a fraction? Well, here's what we can do. Since I know that the greatest common factor, the biggest number, it's a fancy way of saying the biggest number that can divide evenly into both of those is 4, I already know that if I divide this fraction by 4, it'll be done. There's no way to simplify it any further. I can skip all of those extra steps. I don't have to keep dividing by 2 or try to divide by 3 or try to think to myself, oh, geez, I don't know what other numbers I can divide this into. I found the greatest common factor, so I know if I divide by this number, I'm going to automatically get the simplest fraction possible. If I divide 12 by 4, I get 3, and if I divide 20 by 4, I get 5. 3 and 5 are both prime numbers. There is nothing more I can divide those both by, and 3/5 becomes your simplified fraction. So greatest common factor simply tells me the number I need to divide by in order to get my simplified fraction. Now, you might say, whoa, 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 whoa. That's a lot of extra work. If I'm simplifying 3/6, I can do 3/6 in my head. I can do 3 divided by 3 and 6 divided by 3, and I can get 1/2. I don't need to do greatest common factor. This is a method that works better when you're working with bigger numbers, like 12/20ths, or numbers that you can't do in your head, or numbers where you get stuck with a factor and you go, oh man, I can't remember which factor this works with. Greatest common factor helps you figure out simplified fractions when you're working with something a little bit trickier. Let's try another fraction. So let's try 18 24ths. 18 24ths. Now, one way I could solve this is I could keep dividing by 2. That's the old school method. I could just keep going. 2. Now I can divide these by 3. And if I keep dividing by 3, I get 3/4, and I'm done. But if that's a little trickier for you, if you're not quite sure how to work with those numbers, let's factor them down, get the greatest common factor, and then use that number to divide. So we're going to start off by factoring down 18 and getting the prime factorization of 18. So I'll do 2 and 9. 2 is prime. 9 I can factor into 3 and 3, and those are both prime. So for 18, I get 2, 3, and 3. Now if I factor down 24, I can do 2 times 12, that's prime, and then I can do 2 times 6, that's prime, and then I can do 2 times 3, these are both prime. So for 24, I would get 2, 2, 2, and 3. Now, if I draw my little Venn diagram, I'm going to put the numbers they have in common. They have one set of 2 and one set of 3. I'll put those in the middle. 18 had a 3 left over, and 24 had 2 2s. Now, remember, greatest common factor, look at the middle. Multiply the numbers in the middle. Your product of 2 times 3 equals 6, so my greatest common factor between 18 and 24 is 6. Now, 6 is the number that I want to use to divide. It's the biggest number I can evenly divide into 18 and 24. So rather than factoring down, factoring down, factoring down, rather than keep making smaller fractions, now that I know the greatest common factor, I'm going to make it nice and easy. I'm going to divide 18 by 6 and divide 24 by 6, and I'm now going to have the smallest fraction I can possibly make. So again, using this method is better when you're working with bigger numbers or you're working with numbers that are confusing. If you can take a little old number like 5/10 and factor that down in your head and figure out, oh, I can divide both of them by 5, then this isn't the method for you. But if you're working with bigger numbers like 18/24, or things where it's a little bit trickier for you to keep factoring down, or if you even get a little tricked by trying to figure out numbers, use the greatest common factor. Your numbers are always nice and small, and you're never going to have to figure out how many times do I have to divide. All you're going to do is divide once. Let me show you one final problem, and then we'll be done. Let's try 20 24ths. 20 24ths. Again, I could keep dividing by 2, or I could keep dividing by 4, but I want to make it nice and simple. I'm going to do the prime factorization of 20, and I like prime factorization because I can always start with something small. I can start with like 2, 3, 5. So 2 times 10, that's prime. 2 times 5, excellent. So for 20, I get 2, 2, and 5. 2, 2, and 5. Now for 24, I'll do 2 times 12. I'll do 2 times 6. Whoops. Let's try that again. 2 times 12, 2 times 6, and then I'll do 2 times 3, and those are both prime. So for 24, again, I have 2, 2, 2, 3. All right. Now, in order to figure out our greatest common factor, I'm going to take the numbers they have in common, one set of 2 and another set of 2, write those in the middle, and then I have some numbers left over. My GCF is the product of the numbers in the middle, so my GCF, my greatest common factor, is 4. Now, I know this greatest common factor equals the biggest number that I can evenly divide into 20 and 4, into both 20 and 4. So I know if I divide both 20 and 24 by 4, I'm going to get this simplified fraction. This will end up being the smallest that you can get. You can't simplify it any further. All right, guys, try using prime factorization to simplify fractions at home. Good luck, and I know you guys can rock it.